Imagine spending tens of millions of dollars to upgrade a legacy ERP system, right? Like getting your entire global supply chain onto this beautiful modern platform, only to realize that the custom apps your business relies on every single day are completely broken.
Yeah, it happens way more often than anyone actually likes to admit,
Mhm.
because historically developers would just write custom code directly inside that core ERP.
Right, right.
Like they needed a specific report or, a unique user interface, so they just went into the back end and modified the core system itself.
Just hard coding it right in there.
Exactly. But the moment you try to upgrade that system, all those custom modifications just shatter, and suddenly your multi-million-dollar ERP is completely paralyzed.
Which is just a nightmare. And that is the exact nightmare the clean core strategy is designed to prevent, isn't it?
It is, yeah. You keep the ERP pristine, you lock it down,
Yeah.
and you build all your custom extensions like the new mobile apps, the advanced analytics, you build them side by side in the cloud.
But, I mean, that creates a massive new architectural headache for you. How do those dynamic cloud apps securely talk to a lockdown on-premise core without, compromising it?
That is the defining challenge for enterprise architects today. I mean, you need absolute security, but a business has to communicate to survive. The drawbridge has to come down right, but only for the exact right requests.
Authenticated perfectly.
Right, and routed securely.
So today, we are tearing down SAP Business Technology Platform connectivity. We're going to map out the exact architecture that makes this secure communication possible for you, dig into the configurations you need to actually deploy it, and explore the precise mechanisms behind the SAP Cloud Connector and destination services.
Yeah, and we are pulling this directly from the official SAP course materials for operating SAP BTP. We're treating this as a highly structured, hands-on architectural blueprint.
Because understanding this on a theoretical level just isn't enough anymore. If you are operating in a modern SAP landscape, you need to know exactly how to build these bridges.
Absolutely. And perhaps more importantly, you need to know how to avoid the configuration traps that can, literally expose your entire internal network to the open internet.
Yeah, we'll definitely get to that trap. It's a big one.
Yeah.
But first, I want to look at how SAP BTP handles this structurally, because the documentation points to a dual-pillar architecture.
Right.
Instead of having one massive tool that handles everything, SAP breaks the problem of connectivity down into two distinct services. You got the SAP Connectivity Service and the SAP Destination Service. Why decouple them like that?
It really comes down to separating the physical infrastructure from the routing logic.
Okay, how so?
So the connectivity service is the infrastructure. It acts as the proxy. Think of it as the actual physical pipe.
The pipe.
Yeah, it's the pathway that allows data to travel securely from a public cloud environment into a heavily fortified private on-premise network.
But a pipe is completely useless if you don't know where to send the water.
Exactly. The connectivity service provides the mechanism, but it has no idea what your target system actually is, and that is where the destination service steps in.
Okay.
If the connectivity service is the pipe, the destination service is the address book.
The address book that holds, like the URLs, the authentication credentials, all that stuff.
Yep, all the specific configuration parameters an application needs to actually make that handshake with a remote system. It stores all of that technical information securely.
Makes sense.
So when we talk about making a connection, the first thing we have to evaluate is what kind of connection we are actually making. Because the materials outline two fundamental types.
Okay.
The first is internet connectivity.
Which I imagine is the less complicated of the two, right? Like, if an app running on SAP BTP needs to pull in live exchange rates from a public financial API or, grab weather data, the cloud is already on the internet. It's just a standard web call.
Yeah, it is much more straightforward. Internet connectivity is just reached via standard HTTPS. You don't need complex middleware to reach out to a public resource. The SAP BTP environment handles that native outbound request seamlessly.
Nice and easy.
Right. But the second type of connection is where the architecture gets incredibly rigorous, and that is cloud to on-premise connectivity.
Ah, right. This is the scenario where you need to tap into the legacy servers sitting in your company's physical data center.
Oh,
The ones completely insulated behind layers of corporate firewalls.
exactly.
And I mean, if I'm a security admin, my baseline stance is just no. I am never opening an inbound port on my firewall to let public cloud traffic just walk into the data center. It violates, like, every rule of network security.
And honestly, no security professional should ever allow that.
Right.
Opening an inbound port exposes your internal network to port scanning, denial of service attacks, direct external exploitation. It's a nightmare.
Yeah, you just don't do it.
So, because of this, standard HTTPS traffic simply cannot route directly into a corporate data center. The training material dictates that for cloud to on-premise connectivity, you absolutely require a dedicated piece of middleware to act as the mediator.
Which brings us to the SAP Cloud Connector.
Yeah.
And, I was looking through the source text, and I was genuinely surprised to see that this critical piece of enterprise infrastructure is just a free software download. Like, it's available straight from the SAP Tools repository at tools.hana.ondemand.com.
Yeah, it is entirely free, but its role is monumental. You basically download the Cloud Connector and install it on a machine that sits inside your on-premise system landscape.
Okay.
Usually this goes on a dedicated server in the connectivity or like the DMZ layer. Its sole purpose is to create and manage a secure, encrypted, bidirectional tunnel through the internet, linking your SAP BTP subaccounts directly to your on-premise systems.
Okay, so I really want to unpack the mechanics of this tunnel.
Yeah.
Because this is where the genius of the architecture really lies.
Oh, absolutely.
We just established that the corporate firewall is going to block any inbound request originating from the cloud, right? So how does this tunnel actually get built without the firewall just cutting it off at the knees?
It works by utilizing a really fascinating principle called a reverse invoke proxy.
A reverse invoke proxy.
Okay.
Usually, like if I'm at my desk in a corporate office and I click a link, my computer reaches out through the firewall, grabs a web page, and brings it back.
Right, a standard outbound request.
And the firewall allows the data back in because my computer initiated the call from the inside. But here, the cloud app is on the outside, trying to get data from the inside.
Yeah, and if the cloud connector functioned like a standard proxy, the SAP BTP cloud would knock on the external firewall, and the firewall would just drop the packets immediately. It would say, I don't know you, goodbye.
Right.
The reverse invoke proxy turns that dynamic completely upside down.
I was actually thinking about how to visualize this. It's not just like a bouncer at a club.
Yeah.
It's more like, it's like an embassy inside a foreign country.
Oh, I like that.
Right. The cloud connector sits physically inside the local territory, your secure internal network. It operates under the cloud's rules, but because it is already inside, it makes the outbound call to the SAP BTP cloud to establish the connection.
That is a phenomenal way to picture it, yeah. The Cloud Connector initiates a standard outbound web request, typically over port 443 for HTTPS, reaching out to the SAP BTP environment.
Right.
And because almost every corporate firewall is configured to allow secure outbound web traffic, the firewall sees an internal machine making a standard encrypted request, and it just allows it through.
And once that handshake happens from the inside out, the tunnel is established?
Yes. The Cloud Connector holds that encrypted tunnel open persistently.
Wow.
And because the connection is inherently bidirectional, the SAP BTP Cloud can now send requests back down that pre-established tunnel into the on-premise landscape. The end result is that you have a fully functional, highly secure two-way communication channel, and you never had to open a single inbound port on your firewall.
It's just such an elegant solution to a massive security roadblock.
It really is.
But, an architecture like this introduces a completely different kind of risk. Like, if all your cloud extensions rely on this one tunnel to pull live ERP data, and the physical server hosting your cloud connector loses power or its OS crashes during an update,
then the tunnel drops instantly. Any cloud application relying on real-time on-premise data just stops functioning. The business grinds to a halt.
Yeah.
From an architectural standpoint, the course materials are explicit about this warning. A standalone cloud connector is a textbook single point of failure, or SPOF.
Right. So what is the architectural mandate for deploying this in a real-world productive environment?
You must implement high availability, or HA. You simply cannot deploy just one cloud connector instance in production.
Okay, so you need a backup.
Exactly. You set up a primary connector and a shadow connector. They monitor each other constantly. If the primary instance goes down for any reason, the shadow instance instantly takes over the tunnel configuration and reestablishes the connection, ensuring the cloud applications experience, minimal to no disruption.
And I imagine you can't just set it up and walk away, right?
Yeah.
You'd need serious telemetry on this.
Absolutely. The texts stress the necessity of monitoring and alerting. You need infrastructure monitoring on the host machine, so CPU, memory, disk space, and you need application-level monitoring on the tunnel itself.
Because if it slows down, everything slows down.
Right. If latency spikes or the tunnel drops, your IT operations team needs an alert before the end users start, submitting a flood of support tickets.
Makes total sense. So we have the theory of this reverse invoking high availability embassy sitting in our network. How do you actually interact with that? Let's talk about the operational mechanics.
Sure.
You've installed it on a local server. How do you, as an administrator, configure it to talk to the cloud?
Management is handled entirely through a web-based interface called the Cloud Connector Administrator. By default, you access it by navigating to https://localhost.18443 on the machine where it's installed.
Okay, localhost 0.8443.
Yeah.
When you log into that dashboard, how is it organized? Like, what are the levers you can actually pull?
Conceptually, the interface is split. The navigation menu on the left side is dedicated to global settings. This is where you manage the health and security of the Cloud Connector itself, completely independent of whatever cloud accounts it might connect to later.
So this is where you'd configure the high availability setup we just talked about.
Exactly. High availability, alerting configurations, overarching security settings, and the hardware metrics monitor. All of those global operational controls live on the left.
Got it.
The main view, however, is where the actual connectivity magic happens. This is where you link your on-premise connector to specific SAP BTP subaccounts.
All right, let's walk through that exact process for you, the listener,
Yeah.
because this is an action item. If you are tasked with linking a cloud connector to a new development subaccount, what specific data points do you need to execute that connection?
If you are configuring it manually, you need 3 precise pieces of information. First, the region. Second, the subaccount ID. And third, the administrative user credentials for that subaccount.
I want to clarify the region and subaccount ID because they could be slightly opaque if you aren't familiar with the BTP cockpit.
Yeah, you find both of those on the overview page of your specific subaccount in the SAP BTP cockpit. The subaccount ID is not a friendly name, by the way.
Right, it's not like dev account.
No, it is a generated universally unique identifier, a UAUD. It's a long, specific alphanumeric string.
Okay, and the region?
The region represents the physical data center and the infrastructure provider hosting your BTP environment. So for instance, it might be AWS in Frankfurt or Microsoft Azure in US East.
Actually, the documentation drops a really great troubleshooting nugget here regarding that region dropdown.
Oh, right, the version mismatch.
Yeah. It notes that if you are in the Cloud Connector administrator and your specific cloud region simply isn't showing up in the list, it's not a cloud issue, it means your local Cloud Connector software is outdated and lacks the latest region mappings. You just have to patch it.
That is a classic friction point that can waste hours of troubleshooting if you don't know it. Now, while you can type all of this in manually, there's a much more resilient method SAP provides.
Oh.
Instead of manual entry, you can use an authentication data file approach.
Which acts like a prepackaged configuration file, right?
Precisely. In the SAP BTP cockpit, under the connectivity menu, you navigate to Cloud Connectors. There is an option there to download authentication data.
Oh, that's handy.
Yeah. This generates a secure file containing all the routing and identification data for that subaccount. You simply upload that file into the Cloud Connector Administrator, and it populates the connection details automatically. It completely eliminates the risk of copy-paste errors or typos.
But even with that, authentication is notoriously finicky. The course material explicitly highlights a scenario where developers, particularly those using their personal SAP IDs, attempt to bind a subaccount and repeatedly get slammed with invalid credentials or not authorized errors.
Oh, yeah.
Even when they are staring at the correct password, it just fails.
This is a major roadblock for many teams. When this happens, the source text points developers directly to a specific document, and you should probably write this down, SAP Note 3085908.
Okay, SAP Note 3085908. What exactly is failing under the hood to cause that error?
It largely stems from the ongoing migration of SAP user identities.
Ah.
Developers traditionally use an S-user ID, right? But SAP has been shifting toward SAP universal IDs that link multiple accounts together.
Right.
So when the Cloud Connector tries to authenticate against the BTP identity provider, a conflict between a legacy S-user ID and a new universal ID can cause the authentication flow to fail, even if the credentials you typed are technically correct.
That is frustrating.
Very. But that SAP note provides the exact steps to resolve the identity conflict and allow the Cloud Connector to authenticate successfully.
That is a brilliant piece of practical knowledge. Okay, so let's assume we've navigated the identity conflict, we authorize the connection, the tunnel establishes, and the dashboard lights up green.
Great.
We go back to our SAP BTP cockpit in the cloud,
Yeah.
look at the Cloud Connectors menu, and we see our on-premise system listed as connected. The bridge is built. The cloud can now pull whatever data it needs from the back end.
Stop right there.
Oh,
Because what you just described is the single most common and potentially dangerous misconception about this architecture.
okay, correct me. The tunnel is established. The sub-account is linked. Why can't the cloud pull data?
Because the Cloud Connector operates on a strict fundamental principle of deny all.
Ah,
Simply connecting a sub-account establishes the physical tunnel, yes, but the Cloud Connector will actively block every single packet of data attempting to pass through it until you explicitly configure what is allowed. Out of the box, 0 backend systems are exposed.
wow. Okay, so it's basically an empty pipe with a locked valve at the end.
Exactly.
So how do we actually open the valve for a specific application?
You have to build a mapping. Inside the Cloud Connector Administrator, under the Cloud to On-Premise section, you define the internal host, which is the actual IP address and port of your internal SAP system,
Okay.
and then you map it to a virtual host and port.
So you essentially create a fake internal address so the cloud never actually knows the true IP of your backend servers.
Yeah.
That's a really smart layer of obfuscation.
It is. But mapping the server isn't enough either.
Of course not.
You have to map the specific data resources as well.
Right.
For a legacy SAP ABA system, these resources are managed by the Internet Communication Framework, or the ICF.
Yeah.
Let's say you have a custom SAP gateway service that provides sales order data.
Okay.
You cannot just tell the Cloud Connector, allow access to the ABA server. You have to explicitly define the exact URL path of that specific ICF service and add it to the Cloud Connector's approved resource list.
Okay, I want to look at this from the perspective of a developer under pressure.
Okay.
Let's say I'm building a massive side-by-side extension in the cloud, and it needs to pull data from, I don't know, 30 different OData services on the ABP backend.
That's a lot of services.
Right. And the idea of logging into the Cloud Connector and manually typing out 30 different highly specific URL paths sounds agonizing.
It is tedious, yes.
But I know that all ICF services on an ADP system sit under a common root path, which is SAP.
I see where you're going with this.
If I'm under a sprint deadline, why wouldn't I just expose the root path SAP, check the box that says include all subpaths, and instantly grant access to all 30 services with a single rule?
Because doing so is an architectural catastrophe.
Oh, wow.
Yeah. The course texts provide a massive highlighted warning about exactly this scenario. Exposing the SAP root path in a production environment fundamentally breaks the security model of your entire ERP landscape.
Walk me through the mechanics of why that is so dangerous. Like, if the cloud app only calls the 30 services it needs, what's the actual threat?
The threat isn't the cloud app, right? The threat is what else lives under that SAC directory. It doesn't just contain your custom OData services. It contains the administrative interfaces. It contains endpoints capable of triggering background system jobs. It contains deep system monitoring and legacy web GUIs.
Oh, I see.
If an attacker manages to compromise a cloud application running in your SAP BTP subaccount, and you have exposed the SAP root path, that attacker now has a direct, unimpeded highway into the administrative core of your on-premise ERP.
So they could bypass the cloud application entirely and just start hammering the back-end admin interfaces through the established tunnel.
Precisely. The Cloud Connector is designed to provide network-level security. By using a wildcard on the root directory, you strip away that network security entirely.
Right.
And you force the application layer of your ERP to perfectly authenticate and authorize every single request across thousands of legacy endpoints. It is an impossible security posture to maintain.
So the rule is absolute. Practice the principle of least privilege. You define the exact paths you need and absolutely nothing more.
The course explicitly states that exposing SAP should only ever happen in isolated sandbox environments to accelerate early prototyping. It must never touch a productive environment. Taking the time to map the individual resources is simply the cost of keeping your clean core secure.
Okay, the warning is clear. Don't do it. We've built the tunnel, we've mapped our internal systems to virtual hosts, we've securely exposed only the specific ICF paths we need. The infrastructure is flawless.
Yep.
But if I'm a developer writing code in SAP BTP, how do I actually instruct my application to route its traffic through this specific tunnel? Because that requires transitioning from the infrastructure layer to the routing layer.
Exactly. And this is where we bring the SAP Destination Service fully into the picture. We established earlier that destinations are the address book, but functionally, they are discrete configurations in SAP BTP that define outbound communication links from your application to remote systems.
I initially assumed the destination service was managing incoming data too, like filtering requests coming into the app.
Yeah.
But looking at the architecture, it is strictly defining the outbound links, right?
That is a very common misconception, actually. Yes, it is strictly outbound from the perspective of your cloud application.
Okay.
When your app needs to reach out to the world, whether that's to a public internet API or down through the cloud connector to an on-premise ERP, the destination defines how that outbound call is constructed.
And the brilliance of this is completely decoupling the connection logic from the source code, isn't it?
100%.
Because if you are a developer, the absolute worst practice is hard-coding an IP address or an authentication token directly into your application code.
Oh, it creates a brittle, unmaintainable system. If the backend security team decides to rotate a password, or if the internal IP address of a server changes, a hard-coded application immediately breaks.
Right.
You would have to crack open the source code, update the credentials, run it through your entire testing suite, and redeploy the app, just for an IP change.
But with destinations, the app doesn't know the IP address. It only knows a symbolic name.
Exactly. Let's walk through the actual data flow of how this works in practice, based on the 5-step process outlined in the text.
Let's do it.
Step 1. A business user is working in your cloud app, and they click a button to load a customer profile.
Okay, user initiates the action.
Step 2. The application realizes it needs remote data. It does not try to call the ERP directly. Instead, it makes a call to the destination service and asks for a destination by its symbolic name, something like ERP customer data.
Right. Step 3. The destination service looks up ERP customer data in its directory. It retrieves the URL, grabs the stored authentication credentials, checks the proxy type to see if it needs the cloud connector, and hands all of that assemble routing logic back to the application.
Yep. Step 4. Armed with the exact routing instructions, the business application now executes the actual call to the remote system, pulling the requested customer profile.
And step 5, the data flows back into the application and is rendered on the user's screen.
It's an incredibly resilient architecture. If the backend IP changes, you don't touch the application code at all. An administrator simply logs into the SAP BTP cockpit, updates the URL in the destination configuration, and the very next time the app asks for ERP customer data, it gets the new routing instructions instantly.
That's so smooth. But where do these destinations actually live? Because the course materials point out that you can define destinations at 2 different levels within the SAP BTP hierarchy.
Right.
And understanding the difference between those levels is critical for security.
It really is. This is what we refer to as the priority clash. You can create a destination at the subaccount level, or you can create it at the service instance level.
Let's explore the subaccount level first.
Yeah.
If I log into the cockpit and create a destination there, what is the scope of its visibility?
A destination created at the subaccount level is globally available to every single resource within that subaccount. Every deployed application, every background job, every service can potentially see and attempt to utilize that destination.
Which, that sounds great for ease of use, but terrible for the principle of least privilege.
Exactly.
But what if that destination holds high-level administrative credentials for an HR backend system?
Yeah.
I might only want one highly secure application to have access to that, but by putting it at the sub-account level, a completely unrelated, perhaps less secure application could theoretically call it.
Precisely. Which is why you have the alternative, creating the destination at the service instance level. In this scenario, you create the destination directly within a specific deployed instance of the SAP destination service.
And how does that restrict visibility?
A destination created at the service instance level is hermetically sealed. It can only be accessed by applications that have explicitly established a service binding to that specific instance.
Oh, wow.
Yeah, if an app isn't explicitly tethered to that instance, it cannot see the destination, period.
That is a much stronger security boundary. But what happens if, say, a developer creates a destination named backend or RP at the broad sub-account level, and a different team creates a destination with the exact same name, backend or RP, at the bound service instance level? When an app bound to that instance calls backend RP, which one does it get?
The system follows a strict hierarchy. The texts explicitly clarify that service instance destinations have higher priority than sub-account destinations.
Okay, so it checks local first.
Right. The application will check its local bound service instance first.
Yeah.
If it finds a match, it uses it and stops looking. If it doesn't find a match, it falls back and searches the broader sub-account level.
So the architectural rule of thumb for you, the listener, is clear. Default to creating destinations at the service instance level to enforce tight security and least privilege.
Definitely.
Reserve sub-account level destinations for broad, generic utilities, like a public weather API that 20 different apps might need to hit.
That is exactly how enterprise architects structure their landscapes.
Okay, so we have covered the fundamental architecture, the mechanics of the Cloud Connector Tunnel, and the theoretical routing logic of destinations.
We've covered a lot.
I want to transition into the developer's toolkit now.
Yeah.
If we actually need to build one of these destinations, the texts outline 4 distinct methods for creating them.
The first method is the most accessible, which is the SAP BTP cockpit. This is the manual UI approach. You log in, navigate to connectivity, click destinations, and fill out the web form.
But the text notes a UI quirk here that catches people off guard when they are trying to create service instance level destinations.
Oh, yeah. The interface for creating a destination at the service instance level looks identical to the sub-account level. The fields are the same.
Wait, really?
Yeah. The only difference is the navigation path you take to get there. You must explicitly click into your deployed destination service instance from the sidebar, open its specific dashboard, and then click New Destination. If you just click Destinations from the main sub-account menu, you are creating it globally.
A small navigational detail with massive security implications. Good to know. What is the second method?
The Destination Service REST API. This is heavily utilized in the Cloud Foundry environment. Instead of clicking through a UI, developers can write scripts that call specific API endpoints to dynamically create, update, or delete destinations programmatically.
Perfect for automated infrastructure provisioning.
Yeah.
The third method ties into that as well, doesn't it? Using an MTA descriptor.
It does. MTA stands for Multi-Target Application, which is SAP's packaging model for complex cloud deployments. When you are writing an application as code, you can define your destinations directly in the mta.yaml deployment descriptor file.
Nice.
So when you push your application to the cloud, the deployment engine reads that file and automatically provisions the destinations alongside the application.
That is true infrastructure as code. You eliminate the human error of someone forgetting to manually configure a destination in the production environment after the app is deployed.
Exactly.
And the fourth method.
Service instance creation. When you are programmatically spinning up a new instance of the destination service, you can pass a JSON configuration file as a parameter. The instance is basically born with those destinations already configured inside it.
That's super efficient.
Yeah.
Now, regardless of which method you use, every destination requires you to define a destination type, right?
Yes.
You are essentially dictating the protocol, the language the app will use to speak to the remote system.
The text lists 5 primary types. The most ubiquitous is HTTP, or HTTPS. This is the standard web protocol used for consuming REST APIs, OData services, or any public internet resource.
I imagine standard web protocols aren't enough if we're trying to talk directly to older native SCP functions, though. Are we using RFCs for that?
Exactly. RFC stands for Remote Function Call. This type is highly specific to the SAP ecosystem.
Okay.
An RFC destination provides the configuration necessary to communicate natively with an on-premise ABAP system, allowing the cloud app to execute internal ABAP functions directly, bypassing the need for a web service layer entirely.
It's a direct line to the legacy core. What are the other 3 types?
You have TCP, which allows for low-level socket communication. You have LDAP, which is critical for identity management.
Like Active Directory.
Exactly. You use LDAP destinations to connect your cloud environment to on-premise directory services, like Microsoft Active Directory, to perform user lookups or authentication syncs.
Makes sense.
And finally, you have Mail, which configures SMTP, POP3, or IMP protocols so your cloud apps can send and receive emails through corporate mail servers.
Okay, let's say we are setting up a standard HTTP destination to pull data from our on-premise ERP. We input the URL of the virtual host we defined earlier. But how does SAP BTP actually know that this specific destination needs to route its traffic down through the Cloud Connector tunnel rather than just throwing the request out onto the open internet?
This is a really critical configuration parameter. Inside the destination setup, there's a field called proxy type. By default, this field is set to Internet.
Okay.
If your target system lives behind the Cloud Connector, you must explicitly change the proxy type to exactly on-premise one word, capital O, capital P.
If you forget to flip that switch.
The destination service will attempt to resolve your internal virtual host URL on the public DNS servers. It will fail instantly, and your app will crash with a network timeout. Setting proxy type on-premise is the explicit instruction that tells the routing logic to push the data down the established tunnel.
Okay, got it. Beyond the URL, credentials, and proxy type, the course material dives into additional properties.
Yes, the fine-tuning knobs.
These are essentially key value pairs you can append to a destination to fine-tune how the connection behaves.
Yep.
And the texts provide a very specific, actionable example regarding SAP Business Application Studio.
Right. SAP Business Application Studio is the primary cloud-based development environment in BTP. If a developer is using it and they want to connect their workspace down to an on-premise ABAP system to pull in metadata or deploy newly written code, simply providing the URL isn't enough.
Right.
The environment requires very specific property flags to understand the capabilities of that connection.
Let's break down the exact parameters the texts say you need to add, because missing just one of these means your development environment won't sync.
Let's do it.
First, handle redirects. True. What does that do?
Often, when you hit an initial endpoint on an ABAP system, it might redirect you to a specific authentication handler or a different internal node. Setting this to true tells the destination service to automatically follow those HTTP redirects seamlessly rather than failing on a 302 status code.
That makes sense. The next one is HTML5.dynamic destination policial. Why is dynamic routing necessary here?
So the SAP BTP architecture heavily utilizes an app router to manage application endpoints. If you don't set this property to true, the app router essentially gets amnesia regarding the destination.
Amnesia.
Yeah, it won't know how to dynamically forward the developer's requests based on the destination name. This dynamic capability is critical when a developer is writing code that needs to be tested across multiple different backend environments, like switching between a dev and QA backend on the fly.
The third parameter is Webby enabled. True, which honestly seems slightly contradictory given that Webby is the legacy predecessor to Business Application Studio.
It's a legacy flag, yes, but Business Application Studio is built on an evolutionary path from WebAD. It still looks for certain fundamental compatibility flags to verify that a destination is safe and configured for developer tooling interaction, rather than just being a dumb data pipe.
Ah, okay. And the final parameter is WebAD usage. The text explicitly recommends setting this to DataBAP, ODataBAP.
This is the most crucial flag for the developer. It acts as a capability declaration.
Okay.
By adding DataBAP, you are telling Business Application Studio this destination supports deploying and managing native ABAP code. By adding ODataBAP, you are confirming this destination can be queried for OData service metadata.
So without these flags, the studio might connect to the system, but it won't offer the developer the correct tools or wizards to interact with it.
Exactly. You essentially have to tell the IDE what language the backend speaks before it will even try to have a conversation.
The text also mentioned you might need properties like HTML5, timeout to extend connection limits for slow legacy systems, and SAP client to specify exactly which client partition in the ABAP system you are attempting to log into.
Yeah, these properties are the microscopic fine-tuning knobs that elevate a basic network connection into a seamless, intelligent integration between the cloud and the core.
But configuring all of these properties perfectly, the URL, the proxy type, the authentication, the WebAD flags, it takes a lot of time. If I have built a complex destination in my development subaccount and I need to move my application to the quality assurance subaccount, I absolutely refuse to sit there and retype all of those properties manually.
And SAP anticipated that, thankfully. The platform provides robust lifecycle management for destinations.
Okay.
From within the BTP cockpit, you can export any destination. The system packages all the configuration data, the URL, the properties, everything except the raw passwords into a file.
What formats does it support?
You can export it as a standard JSON file, a YAML file, or a classic key value properties file.
So you just download the JSON file from development, log into the QA subaccount, hit the import button, and upload it.
Exactly. It's vital for maintaining consistency across DTAP landscapes, development, test, acceptance, production. You can even use the export-import function as a quick cloning mechanism.
Oh, like templates.
Yeah. If you need to create 5 similar destinations, you export the complex template, change the URLs in the JSON file using a text editor, and import them all in one batch.
We have dissected the entire architecture. We understand the dual pillars of connectivity and destination services. We've analyzed the reverse invoke mechanics of the cloud connector, navigated the disaster of exposing the SAP path, and mapped out the precise configuration of destinations.
We've covered the theoretical and the structural, but the true value of this deep dive lies in the application.
Absolutely.
The course materials are designed to be actionable, and we want to ensure you have a clear roadmap for putting this into practice.
Right. Based on the source texts, there are 4 specific architectural experiments or tasks that you can execute in your own SAP BTP environment to solidify these concepts. If you want to see this reverse invoke mechanic in action, your first step is simply getting familiar with the telemetry.
Log into your SAP BTP cockpit, navigate to the connectivity menu, open the Cloud Connectors dashboard, and audit the state of your infrastructure. What regions are connected? Are the tunnels active?
And once you understand the dashboard, the next actionable step is to manually establish a connection. If you have a sandbox environment, download the free Cloud Connector software, deploy it locally on localhost port 8443, and walk through the authentication process.
Map your region, your UUID, and practice using the authentication data file approach versus manual entry. And if you hit an authorization wall, remember that SAP Note 3085908 is your lifeline for universal ID conflicts.
Your third step is to actually build the routing logic. The course explicitly suggests building a test destination pointing to the North Window Data Test Service.
Right. It's a public internet database, so setting this up will test your internet connectivity architecture, ensuring your BTP environment can execute outbound HTTP calls correctly before you tackle the complexity of routing through the cloud connector.
And finally, practice the lifecycle management. Export that Northwind destination as a JSON file, delete it from your subaccount, and use the import tool to recreate it. It proves that you can manage your infrastructure as code rather than relying on manual UI clicks.
Executing those configurations bridges the gap between understanding the theory and commanding the architecture. Now, before we conclude, there is one major environment caveat that the texts raise, and it fundamentally impacts how you implement everything we've just discussed.
It's a critical distinction. Throughout this deep dive, when we've discussed interacting with the Destination Service REST API or deploying via MTA descriptors or the specific behavior of the app router, we have been operating under the assumption of the SAP BTP Cloud Foundry environment.
Because Cloud Foundry is the most ubiquitous runtime environment for these types of custom side-by-side extensions.
It is. However, SAP BTP is a multi-environment platform. It also offers the Kaima environment, which is deeply integrated with Kubernetes, and a dedicated ADAP environment in the cloud.
The source material is very clear. While the architectural concepts, the need for a cloud connector, the purpose of a destination remain constant, the actual technical implementations differ significantly across these runtimes.
So if a team is deploying a containerized application to a Kubernetes cluster in the Kaima environment, the YAML syntax they use to bind a destination to a pod is going to look completely different than the Cloud Foundry methods we covered.
Exactly. The fundamental physics of the connectivity service remain the same, but the engineering of how you connect to it changes. If you are operating in Kaima or the ABAP environment, you cannot assume the Cloud Foundry steps map one-to-one.
You must consult the specific operational documentation for those specific runtimes to handle the bindings correctly.
It's a necessary reminder that context is everything in enterprise architecture.
We set out today to give you a comprehensive, highly technical blueprint for SAP BTP connectivity, and we have navigated some incredibly dense terrain.
We started by framing the absolute necessity of the clean core, understanding that side-by-side extensions are the only sustainable way to innovate. We broke down the dual pillars, the connectivity service acting as the physical infrastructure pipe, and the destination service acting as the intelligent routing address book.
We spent significant time analyzing the cloud connector, realizing that its reverse invoke proxy design, acting like an embassy inside the corporate network, allows for secure, bidirectional communication without forcing security teams to open dangerous inbound firewall ports.
But we also recognize the sheer operational risk it carries, mandating high availability setups to prevent catastrophic single points of failure.
And we cannot stress the security implications enough. When you are mapping your internal resources through that tunnel, the principle of least privilege is non-negotiable.
Using a wildcard to expose the root SAP path in a production environment fundamentally compromises the security of your entire legacy ERP landscape, opening up administrative and background systems to potential cloud-side exploitation.
We then explored how to instruct applications to use that secure tunnel, diving into destinations. We traced the decoupled data flow, showing how symbolic names prevent the nightmare of hard-coded IPs.
We resolved the priority clash, emphasizing that service instance level destinations provide necessary security boundaries that subaccount level destinations simply cannot offer.
And we gave you the precise configurations needed to make these connections function, the necessity of setting proxy type on-premise, and the specific capability flags like Webby usage required to allow developer environments like SAP Business Application Studio to natively interact with older ABAP systems.
You now possess the architectural logic and the exact parameters required to build and secure these critical enterprise bridges.
But we always want to leave you with something broader to consider, a way to look beyond the immediate configuration screens and anticipate where this technology is heading.
We have spent this entire deep dive operating on a fundamental assumption that there is a rigid, highly secured on-premise world and a dynamic external cloud world, and that we must build complex middleware bridges like the Cloud Connector to link them together.
Right. We still treat the physical corporate data center as the undisputed center of gravity.
But the reality of computing is pushing back against that assumption.
It is.
Look at the rise of edge computing. Processing power and data generation are moving further and further away from the centralized data center out to localized edge servers on factory floors or directly onto IoT devices.
As the core itself becomes completely decentralized and distributed across a mesh of hybrid cloud nodes and edge environments, we have to ask a deeply provocative architectural question.
In 5 or 10 years, will the SAP Cloud Connector still be a necessary bridge that we meticulously build from the inside out?
Or will the very concept of an on-premise data center evaporate entirely?
If your core ERP functions are executing as distributed microservices on the edge, there is no centralized fortress left to protect. There won't be an inside to build the bridge from.
The architecture we just mastered might transition from being the critical enabler of enterprise IT to being a fascinating historical artifact of how we used to manage the transition to a fully distributed world.
It is a phenomenal shift in how we think about network boundaries, something to keep in the back of your mind as you configure your next destination.
Thank you for joining us on this incredibly detailed blueprint of SAP BTP connectivity. Now, open up that BTP cockpit, spin up a cloud connector, and start building those secure bridges. We will catch you on the next deep dive.